Today's our second problem is from GATE 2022 Mathematics paper. Problem number 47. And the problem is, let T from R square to R square be a linear transformation defined by T of 1 comma 2 equal to 1 comma 0 and T of 2 comma 1 equal to 1 comma 1. Then for P and Q in R, let T inverse of P comma Q equal to X and X comma Y. Here T inverse is again a linear transformation. Then it is asked that which of the following statements is true. The four given options are: first option is x equal to p minus q and y equal to 2p minus q. Second option is x equal to p plus q, comma y equal to 2p minus q. The third option is x equal to p plus q, comma y equal to 2p plus q. And the fourth option d is x equal to p minus q and y equal to 2p plus q. And this is if we have just known the definition of linear transformation and some the vector space properties and the result which I have mentioned in at the beginning of this lecture. If we know about this much knowledge, we can solve this problem. And the NPTEL reference to solve this problem is Module 4, Lecture 14 of Linear Algebra. And the title of this lecture is Linear Transformations by Professor K.C. Sivakumar. He is from Department of Mathematics. Sorry. He is from Department of Mathematics, IIT Madras. You can even watch this lecture in the YouTube by using this link. So now coming to the useful data from the given problem. We have useful data is given that T is from R square to R square is a linear transformation. And we can observe here that dimension of R square is equal to 2 over the real field. And it is given that E of 1 comma 2 equal to 1 comma 0 and T of 2 comma 1 equal to 1 comma 1. We can observe here that and it is given one more condition that P inverse of P comma Q equal to, and for P comma Q in R, T inverse of P comma Q equal to X comma Y. One point we can observe here that why it is given T of 1 comma 2 and 2 comma 1 only. Since we have already know that dimension of R square equal to 2, and we can see that the vectors 1 comma 2 and 2 comma 1 are linearly independent. Just because one is not a scalar multiple of other, so we can say these two vectors are linearly independent. So, and we can say the set solution starts here. We can see the set 1 comma 2, the set with the vectors 1 comma 2 and 2 comma 1 is a basis for R square over R. It is one of the bases. Since because R square dimension of R square is 2 and these two vectors are linearly independent. In fact, if we take any two linearly independent vectors in R square, those two forms a basis. The collection of those two vectors forms a basis. And we can observe one more point here, that the set and the set with the vectors 1 comma 0 and 1 comma 1 is also a basis for r square over r. So from these two, what we can say, that I can say t is 1 1. But how? Since t maps a basis to a basis, so I can say t is 1 1. So from the result which I have stated at the beginning of this lecture, we can say t is 1 1 on 2, and in fact kernel t is 0. So by using that proposition, we can say, I mean the result, we can say t is bijective. That means T inverse is a linear transformation from r square to r square. So now the question is, what is the value of T inverse of P and Q, P comma Q, when P and Q are in real numbers? Since T inverse is also linear transformation, we can take T inverse of P comma, since T inverse is also a linear transformation, so we can calculate the image of P comma Q with respect to the linear transformation T inverse, but with the given conditions, that these two conditions. So from these two conditions, what we can see, that we have, since we have T of 1 comma 2 equal to 1 comma 0. So from this we can say T inverse of 1 comma 0 equal to 1 comma 2, and T inverse of 1 comma 1 equal to 2 comma 1. This is just from the given data only. From these two conditions. And now, since T inverse is a linear transformation, and it is asked that T inverse of P comma Q is what? So by just writing P and Q, I mean the vector P comma Q in with the linear combination of the vectors 1 comma 0 and 1 comma 1, and then by applying the linear transformation on both sides T inverse, we can simply calculate the value of T inverse of P comma Q. That is, by just writing, we write P comma Q as a linear combination with the two vectors alpha times 1 comma 0 plus beta times 1 comma 1. Then we calculate the value of alpha and beta in terms of P and Q. We get that this is alpha plus beta comma beta. So now by just comparing the coordinates, we get q equal to beta and p equal to alpha plus beta. So that means p equal to, or p minus q equal to alpha. So we have the value of alpha and beta. By just substituting these two in the in this equation, we get, so p comma q can be written as the linear combination with the two vectors as p minus q times 1 comma 0 plus q times 1 comma 1. Now by just simply applying the linear transformation T inverse on both sides, we get, now, by applying the T inverse transformation on both sides, we get T inverse of P comma Q equal to T inverse of, what do we have? T inverse of P comma P minus Q times 1 comma 0, P minus Q times 1 comma 0 plus Q times 1 comma 1, right? 1 comma 1, right? So just by the, then again by the property of linear transformation, or by the definition of linear transformation, we can see that this can be written as P minus Q times P minus Q times T inverse of 1 comma 0 plus Q times T inverse of 1 comma 1. But by the given conditions, we already have the values of T inverse of 1 comma 0 and T inverse of 1 comma 1. So by just substituting those two values, we get this as 1 comma 2 plus Q times 2. Sorry. So this we get as P minus Q plus 2Q comma 2P minus 2Q plus Q, that is P minus Q comma, this is 2P minus Q. Sorry, this is P plus Q. So, but on the left hand side, we have T inverse of P comma Q, which is nothing but by the given problem, we have that as X comma Y. So by just making those two equal, so X comma Y equal to P plus Q comma 2P minus Q. By just making this two vectors equal, we can say X as P plus Q and Y as 2P minus Q. So X equal to P plus Q and Y equal to 2P minus Q. So from the given options, we have the second option is correct. Answer is B. Thank you.